Here's the next on the list of problems. This one's pretty slick. I like these slice problems. But there are 4 points or 3 points that are plotted. There's 0, 0, 4, 0, and 0, 4. So basically, these are the points kind of located on the axis if you plot them. And it says find the volume, which is a funny thing because you're doing this thing called perpendicular slices. So this is another one of those when you're doing cross sections that are perpendicular to the base, parallel to the y-axis. It has a particular meaning to it. And so what it means is you're literally going to stack on a shape, and it says they're half circles. So I'm going to put on this, I'm going to I'm going to try to make my little half circle piece here. There we go. Like, there's this piece, like here's the top edge of it. And so you basically you put that half circle piece, you lay it on top of this figure here, and you put a bunch of them together. And so here's a half circle, and here's a half circle. And they lay another one next to it, and then it lays across there. It's a little bit, they're different size, a little bit smaller than the one before it. So these cross-sectional slices kind of end up making an area that descends, and eventually you get down to the last one, you get a really little tiny half circle down here that makes the last piece, and you do the volume of that. So it's this kind of descending collection of circles, and if you do an infinite number of them, it's a smooth looking, it would kind of look like a small section of a weird looking cone on the end of an airplane. It would be kind of like I don't know if you ever saw that French supersonic passenger plane with like a tip of its cone nose that wasn't quite straight, had like a weird non-usual cone shape. But anyway, that's the stuff you're laying on top of it. Well, to do this, one of the things, I don't know if I mentioned to you about integrals, is they're an infinite sum. I think I mentioned something like it, of something. You're just adding together a bunch of things is what it really ends up to. And so an integral, when it talks about area, in this case with this, you actually really just want to find the volume of one of these little pieces in terms of an equation, like an x, so that it's dynamic, it changes. Because you notice these are all different shapes as you move along, as you go down descend down as x increases. Because x is going to go from 0 to 4. Remember, these are your lower x and your upper x, your x bounds. So this is x equals 0. And this is x equals 4, your upper bound. That's the region that we're laying the slices on. But all we need is the volume of one of those to put in here. And the integral, its job is to add up an infinite number of those that are infinitely thin. And dx is actually delta x, but it means an infinitely small delta x for each width of those. So delta x is, this little dx is kind of code for a delta x, a change in x, a width of our slice that's infinitely thin. And so this means the s means infinite sum, the dx means infinitely thin. Together, when you add them together, you get an exact volume with laying over these pieces. Okay, so I just need to know the volume of one of those pieces. So I'm going to go over to the side, maybe even another page if I need it. But I'm going to do one piece of it. So this is what I usually do in class. You just draw this picture of one slice that's dx thick. I put it sideways, horizontally. We'd turn this side and put it on vertically, but I just wanted to show you one of them. Maybe I shouldn't. Maybe I should back up. Hang on a second. Let me do it sideways like I should. Probably be confusing looking at it like this. Okay. So here's this one. So let's put it up like this. Actually, here. Yeah, pardon my artistry. I want to make this just perfect, Can't have it. There we go. Let's go this way. There we go. It's a little bit better. But it's going up. Hopefully you get the idea. Despite my lovely drawings. But there it is. This thickness, dx, goes right here. The volume of this is like the volume of any cylinder. So if I'm going to do a cylinder of some kind, what you have to do is you basically get the area of the face of it. So if I just know the radius here, you do pi r squared